We are going to explain the concept of PCA, the principal component analysis. Uh, we are going here to explain the concepts of covariance matrix, eigenvalue and eigenvalue decomposition of how they are used in PCA, and we'll take it through a case study of IPL 2020 Best Bowler. So let's jump in. A brief recap of what is PCA. It is a statistical procedure that allows to summarize information content in large data tables by means of a smaller set of summary indices. So the keyword here is large data tables to a smaller set of summary indices that can be more easily visualized and analyzed. So for the bowler, these are the metrics that we are considering: the number of wickets, the strike rate, which is balls per wickets, the average, which is runs per wickets, and the economy, which is runs per over. And then using PCA, these four dimensions that we saw is being reduced to one. So that's what PCA is doing, so that there is no loss of information, and this will allow us to rank the bowlers. So how we have to do it, these are the steps, and I have taken inspiration from Sebastian's blog. So the first step is standardize the data, obtain the eigenvectors and eigenvalues from the covariance matrix. So that is this is a way that we are going to show you, or you can get it from the correlation matrix or perform singular value decomposition. What we are going to do is that we are going to use this method. We are going to get eigenvectors and eigenvalues from the covariance matrix. Please note that there are separate videos for eigenvectors, eigenvalues, covariance matrix, and please watch them if you are not comfortable with them. So there are videos for that. So the next step is sort the eigenvalues in descending order and then choose the k eigenvectors that correspond to the k largest eigenvalues, where k is the number of dimensions of the new feature subspace. So what is happening here is that you will have since here in our case we'll have 4 dimensions, there will be 4 eigenvalues and 4 eigenvectors. But what we will do is that we will sort them, and we will keep the largest one at the top, and then the lesser ones will follow. What it would do is that in our case we will choose, since we are reducing the dimension from 4 to 1, we will choose the first the largest eigenvalue and the largest eigenvector. Next step is construct the projection matrix W from the selected k eigenvectors, and then transform the original dataset X via W to obtain a k dimensional feature subspace. We will do all these steps with that case study. So let's jump in and see the case study. So here we are having the bowlers. We are having these 4 dimensions: wickets, average, strike rate, and economy rate. And then what we do is that we are scaling it. What does scale do? What it does is just for each column, the mean is 0 after scaling and the standard deviation is 1. So we can see it here. The mean is minus 1 into 10 to the power minus 16, so which is practically equal to 0, and the standard deviation is 1, so 1.021. So that's what we are doing. First we are scaling it, and then we are doing we are calculating the covariance matrix, np.cov. It is an NumPy covariance function. We are getting the covariance matrix, and then we are extracting the eigenvalues and the eigenvectors. Okay, so and then what we are doing is that we are making a list of the eigenvalue, eigenvectors, and then we are sorting the eigenvalue and the eigenvector tuples from high to low, and then what we are doing is that projecting into the new feature space. So here what we are doing is that since there are 4 eigenvalues and 4 eigenvectors, so what we are doing here is that we are choosing only the top 2 eigenvalues and the eigenvectors, and then we are projecting the matrix into the actual matrix that we are given, and we are finding this matrix here. And then all these things which are here is that renaming of the data frame, and then what we are doing is that we are sorting the matrix with the PC1, that is the first principal component, in ascending order, and that's what we are getting here. And if we see it, that we see that Bumrah is the best bowler if you do it in that way, followed by Rabada, Bolt, Chahal, Shami, Archer, Rashid Khan, Norte, Varun, Natarajan, Karan, Chahar, Ashwin, Sandeep Sharma, and Ravi Vishnoy. So what this illustrates is that by using the covariance matrix, by using the eigenvalues, eigenvectors, we can construct the PCA, and then using the reduced number of principal components, so reduced number of eigenvectors, we can reduce the dimension of the data set from, say, here we had 4 and we reduced it to 1. And how we have used it in the business sense, we have used to rank the bowlers. Hope you like this lecture. Thank you. Bye.